Hey folks, it's Wade from the Shoemakers Academy. I know it's been a little while since we've made some videos and we recently were on this we took that big old trip to China and we spent a fair amount of time in tooling shops. So today I want to basically I don't have a real super organized presentation, but because footwear tooling is like pretty much a critical component. I want to just walk you through a bunch of photographs that we took and explain what's going on and sort of let you see, like, we all know what a blueprint looks like, more or less. But what happens when the factory gets that blueprint? What do they do with it, right? How do they take your drawing and turn it, from a prototype into a finished piece of a into a finished midsole or outsole. So we'll talk about that. I want to show you through some pictures here, and I know the order is going to be a little bit mixed up, but this is kind of as we toured, and I'm going to show you some interesting things. And well, let's get to it. Okay, footwear tooling. So we're gonna just go through my photo catalog here, and we'll just go image by image. So this right here is we're in the tooling preparation room, and what we're looking at here is these are gauges. So the green things here, these are the bottom gauges, and this basically is the bottom of the last, but it's also the top of the midsole, right? So you need to have these gauges so that you know that your upper fits correctly down on top of the outsole equipment. I mean, that's the really important part, right? So generally, they'll make a pullover and they'll laser scan it, and then from there they'll grade it, and then they'll make these gauges. So these gauges are what the technicians use to check the parts. And and these orange things over here, these are profile gauges. And actually, here I think there's a little video of me talking about that, and we'll just take a second and you can watch that. So we're here in the R&D center of the tooling shop, and what they have here now is the top net gauge and the outsole profile gauge. So this actually shows you the cross section where your upper sits into the outsole, and then this gauge actually shows you the side view. So you can actually see, okay, for every size of your design, what does the shape of the outsole look like? And they use this to check the tooling before they have to cut all the metal. All right, thanks, Wade. Next one. So here is a whole collection of these. Now, why is there so many of these? Well, there's so many of these is because you have to make one for left and one for right and one for every size, right? So, I mean, that's kind of what makes outsole equipment so expensive, is that you need to open these molds for every single piece. And if it's a combination like this, outsole midsole, then you're going to need the tool for the outsole and the midsole. So actually, two outsoles, two midsoles, that ends up being four pieces of equipment to make one size. And basically, so you say, hey, Wade, roughly how much is this stuff, right? Well, we're talking about compression mold, and I'll show you what that looks like in a second. Just like a big waffle iron. These compression mold tools generally cost about $1,500 per size. Excuse me. Can you find cheaper? Oh yeah, you can. Will a $900 mold be good? Maybe, maybe, and I'll show you what to look for in a second. Okay, so what is this crazy stuff? Okay, so these wooden molds here, this is kind of like a bondo material. It's hard, right? It's really firm. It machines really smooth. You can sand it, you can glue it. It's kind of like filled resin. And whether it's pink or white doesn't matter, right? So here you see they have these wood cuts, right? They actually literally used to make these out of wood. And now it's sitting on the strange base, right? And what is this? What is this base? Let's zoom in on this thing. So what is this base? This base actually is on its way to the casting factory. So they use this setup here to actually cast the metal. And all of this stuff, the shape, this pink stuff, and this white base with the chipped up structure here, that there's going to be a replication of exactly this shape in metal. So what is this stuff? This is actually just the recycled chips poured together with more resin to because rather than just throw the pieces away, right? It's interesting that they do it that way. Okay, so there's that. And here's the technician, and what has he got here? He's got the whole size run of this kit that he's looking at, right? So he's looking at He's looking at some sandal bottoms over here, and then he's looking at some other looks like rubber bottoms, and he's got these little hand tools. What is he doing with these? Well, if you see a small, because this actually goes to the casting process, if you see a little, boogered up edge or something that's wrong, you can fix it. And in this stuff, really they have a little. He's probably got a little tube of repair putty here that he can actually fix all these things. He literally is basically a sculptor. So he's checking the gauges. You can see he's got the last sitting on this sandal footbed to see how it works. And then notice what's in the background here. There's another size run of other equipment here. So when you pull the trigger to make your sizes, there's a lot of stuff that goes on, and here's the guy doing it. Okay, so I think well, here let's see what we have to say here. So here we are checking the wooden mold and also the new technology to use the 3D printing. But these wooden molds, this will go directly into the metal casting process. And if you see, every size has to be done, right? So if you look around this room, you see many of these, what we'd call woodcut, is available to make each size. So what he's doing now is he's checking all the detail, because every detail that's in this woodcut will end up in the metal mold. So here you can see they're checking the last to make sure that it fits the top of the sandal correctly. And here he's looking at all the fine detail. He's got the gauges we saw upstairs, and he's just using a hand tool to make sure all the detail is correct. All right. So yeah, guys got a lot of work to do there. Okay, what's this thing? This color, you see this brown, well, so it keeps jumping around here. Those brown things, these ones here. This is the machine. This is the SLA machine that's making that. And actually, let's try to. We'll turn it on and try to zoom in here. If you can see the laser on the surface, maybe you can see it. All right. And so that thing lasers it, and then it sinks down, and eventually you end up with the whole part in the resin. Now, actually, it's interesting. You see these parts have little holes in them, and that's so all the liquid resin can pour out. So yeah, it's this big machine, right? A pretty fancy one. Okay, that's what that machine looks like. Very common to see, and it's amazing because whilst we're touring, we see these gigantic, mold factory that's like, I don't know, almost a city block. And then you also see these upstairs in a little tiny hole in the wall place has the same machine because it's not so expensive. So here you can see they got a whole stash of these parts. They've got the actual machined ones, and they've got the resin ones. And now actually down here you can see, and we're across the street in the metal shop now. So here you can see this is the metal component. So like I mentioned to you in that other photo, what that thing looks like. Well, here it is. It's got the impression, and it's got those edges on it. And then here is the reverse, right, of that big block, right, where it's got the actual design of the shoe in it. Okay, so these are the raw castings. You can see it's still pretty messy, right? So now they have to go in and start processing. So this is part of the processing. They're doing a little CNC machine work there. Okay. Now what's going on here? So what's going on here is this machine here, and we'll try to zoom in on it. I know it doesn't look like much, but here it is. It's a scanner. And what they're doing, and you see those little reference dots, those are little stickers. They're scanning the raw casting to make sure that it's right. And also, once they have that information, they can go ahead and basically what they're going to do, and I'll show you this in a second, is they're going to get those surfaces of those two molds to match each other so the mold can close tightly, right? And we'll get to that. Okay, so here's all the raw blocks. And what you have here is you have basically the bottom deep section of the mold, right? And then you have the intersection, or what's going to be the inside of the other side of the net is here, right? So these are the two halves of the molds. Why is this? Okay, so these are they can be cast aluminum or cast steel. Some of the big midsole molds are cast aluminum, and some of the other outsole molds that are a little lower can be steel. Okay, so here's the worker. He's you can see that now the mold is starting to be assembled, right? It's got handles on it, it's got hinges on it. And here's this guy. Let's see what he's up to.
Go ahead. Yeah, yeah, yeah.
Okay, so when I say ni hao, I'm saying how's it going, right? So here he's got the pieces now. Okay, let's get back here. We're gonna zoom in on this guy's bench here, so you can see he's got this is the tread side of the mold, right? And then as we play along here, you're gonna see other things. Okay, so now this piece makes the sidewall, okay, and this piece over here, um, it looks like a block with the grooves cut in it. Those grooves turn into a pattern that looks like this, right? So when you see egg crate inside, right? And now I'll show you in a second. I'm going to show you a piece. You see little pins sticking up, and that's how you make these dimples, right? And remember, everything's reversed, right? So that's what that is. Let's just scroll forward. And so he's putting these pieces together. He's probably going to start wailing on it in a second, right? Because obviously they're hammering everything. Why are they hammering everything? Well, I'll show you in a second. So he's just checking to see that everything fits together. Now, it's super important. Okay, so here's the next part. You can see he's got the three pieces of the mold here. And this red stuff. What is this red stuff? Okay. This red stuff is tooling dye. And what this stuff does is you can see he's taken this brush and he's dabbed it all over the surface of this mold. And right here, this is the mating surface, right? These areas need to kiss together. So when you have that dye mold on it, and you put the pieces together, and you basically take another big softer piece of metal and you bang on it. It's in the background of some of these videos. You hear a lot of banging. Is they're trying to get that dye to transfer on the high spots. So they'll open it up, and if they see red dye on this part, then they'll go ahead and they'll give it a little sanding or a little grinding, right? And then eventually you want to get it so when you push those two together, you have red dye everywhere. Then you know that your parting line, right, where the two pieces come together. Okay, what's a parting line, right? Parting line. This is a bad example because it's the colors getting wrong here. I'll show you in a second what a parting line is. Hold on one second. Okay, I'm back. A parting line is this. You see where the white and the black meet? Okay? That is where the two halves of the mold come together. Right? And I'll show you the molding process where they basically sort of put these two pieces separate from each other. They mold it, they cook it about halfway, and then they push it together, right? And I'll show you a two-color unit. But if these mold halves don't fit together perfectly, then rubber is going to squirt out and it's going to make a mess. And you can see on a high-end piece of equipment like this, I mean, this is actually not, I mean, this mold is as simple as it comes, right? However, when you look where these two colors meet, you'll see that the joining line is super, super close. And that's because this is expensive, high-quality equipment. And the guys in the factory spend a lot of time and effort making sure that those mold halves fit together perfectly. And that's really when you're looking at evaluating a piece of equipment, whether you're buying a shoe or you're evaluating a mold that you're buying, is how tight are those parting lines? Because if it's raggedy, if it's raggedy and wavy and you see a little rubber sticking out where it flashes, and I'll show you that in a second, that means the mold's not a well-made mold. Okay, so here's the guy grinding away. Let's just take a look here. And you hear in the back the banging, right? Right, and these guys are all doing this thing. They are just making sure those areas. Now, actually, this one, dang it, hold on. This one, you can see, we'll just zoom over here. This thing looks a little bit, technically speaking, boogered up. What's going on here? What's going on here is they've had to come back and do a little extra welding. And that's what that heat distortion is. So if there's something really wrong, they'll actually get a torch and add some more metal so they can repair it. And then here you can see he's got the molding die all over it as he actually folds the mold together and bangs on it to do the dye transfer. So here you can see they've got all the molds set up. Yeah, metal shavings everywhere on the ground. So this is a pretty busy. This is a pretty busy mold shop. Okay, so what is this? These are all the hinge components, right? You've got the barrels and you got the brackets and you got handles and all that stuff just has to get welded onto the mold half so that it can actually function like a waffle iron. And here are those internal blocks. These are not necessarily cast. They might be made by EDM, which is an electrode that slowly burns away the metal to make those sharp corners. All right, so here's some raw castings. Then now they've got the scan marks on them, and they're going to get ready to get surfaced. Again, you use the CNC machine to make sure that these surfaces are perfectly flat and mate together, right? Okay, so here's the machine, and this guy is a honing machine, and what he's doing is making sure that once you get the mold together and you know they're all flat, you want to make sure that the thing is completely square, right? The sides are 90 and the top is flat. Because when you put this into a big press, right? You got to make sure that it's square, otherwise you're gonna damage the equipment and damage the mold. So he goes through this operation to make sure that those surfaces are perfectly square and flat. All right, that's just me goofing around, but we're just checking out what the guy's up to, and looking at a mold here that's pretty well finished. You see, there's a little bit of mold dye on it, but not much. Okay. Oh yeah. So here we go. So this is a slightly different mold, and what we're looking at here is this is an injection tool, right? And how I know is because this feature right here, this is the inlet, right, for the either rubber or the injection EVA to get into the mold, right? So um, and then you can see these little fingers sticking up. This is what makes this kind of hole. And you can see some of these are in a weird sort of bend like that. It's totally okay because when this mold opens, this material is so soft it can just come out. Not a big deal. Usually, if you have a bent over structure like that, the piece maybe is not going to come out of the mold, but in this case, it's not a problem. So here you can see they've got an inlet, and then also on the end here, this is on the other end. Okay, why do you have this? This is so air can get out, right? Because if you're pushing material into a mold, if there's no place for the air to escape, how does the material get in? Otherwise, it won't go, right? So you got to have inlet and you got to have exit vent. What else is going on here? There's some flex grooves here, right? That's what those are. And you can see this mold. It's got all the detail built into the side of it, and it's got a nice texture for bonding, right? You want to make sure that the surface here has a nice texture for bonding. Here's a close up of that, and there's some of the mold information. If I could flip that around, then you can maybe see what that says. Okay. All right. Here is raw rubber. So this is literally literally they take the latex rubber off the tree and they smoke it to dry it, and it turns into this nice golden color, and and this material ends up getting ground up and mixed to make the rubber. Okay, so here we are. This is the culmination of all that work, right? This is a rubber mold. This is a flat one. You can see all the design detail is in the mold. That green stuff on the mold is Teflon, and this one looks like it could probably use another coat of Teflon. It does wear out, but what you can see here, let's zoom in on this thing. You can see the texture. You can see the hinge. You can see this sort of looks like a little dam around the outside. This is so that when the rubber, because you want the rubber to be able to flow out of the edge, right, to make sure that all of these pieces get filled, right? If you don't have a place for a little rubber to escape, then you might end up with an air bubble on all these edges. So this mold has a little flat edge to let the rubber get out, right? And I'll show you. I think we can jump ahead here. So this is what that looks like. So here you can see all this flashing on the outside. Now you'd be like, wait, this thing looks horrible, right? I mean, what's the deal with this? Well, that extra flashing is what allows the mold to fill, right? So you don't end up with air bubbles in your parts. And then the workers have to come back and trim it off. And that's just part of the process. This is totally normal. Um, is it a bummer that this material gets wasted? Yeah, it is. Does this rubber get recycled? Sometimes they do, right? You can regrind it. Now, you can't just take it and stick it back into the rubber because this rubber has already been vulcanized, right? Now, actually, here, well, let's back up and I want to show you this process a little bit. And you can see that the rubber sheets he's loading into the mold are really flexible. It literally is like, it's kind of like tangy taffy. It really is really pliable. So let's watch that for a second. Okay, so these are just the die cut pieces, right? So they mix the rubber, they roll it out into these sheets, and then they die cut it. And they have, somewhere along the process there's a little bit more rubber in one area to make sure it fills. They just kind of give it a boost with a little extra piece here. Let's finish the video. What's that? Okay, here's the other question here is what is that what is that little spray bottle, right? Well, that spray bottle is a little bit of mostly water or a little bit of detergent, but it's basically mold release. It just helps make sure the parts don't stick to the mold. So, okay, so here it is. Now he's unloading it, and he just peels it out, but you can see how the rubber is flashed out beyond the design of the part, and that's okay because that makes sure that the part's complete. And you see he's wearing the gloves because the stuff is still pretty hot, right? And we're gonna back up here, and I'll show you what's behind him on the workstation there. You can see, oops, gonna have a pause here. You can see what's going on. Let's get back here. You can see back here. We'll pause it. We'll try to zoom in here. All these cut parts here. So these are the pieces that are getting ready to be put into the mold. So this is unvulcanized, right? And vulcanizing is essentially just you're heating up the rubber so that the molecules that are just kind of loose, in molecular strands, that they cross link and they fuse. And that's what makes rubber like really tough. Invented by a guy named Goodyear. Imagine that. Okay. So here's so this is the guy loading the mold, and you can see he's got a whole bank of presses. So maybe there's like maybe 6 or 8 rows, and actually this is a double-sided press because there's another guy in the other bank. As this thing opens, one press goes in, one out, and goes in one, and one goes out, right? And they try to synchronize their work. These guys are getting paid by the piece, so that's why they try to go really quickly. But there's a cycle time for these. You set the temperature. And in a rubber mold, it's just heat because once it's vulcanized, it's done. You can peel it out and it's not gonna get damaged, right? And an EVA mold has to go through a cooling process. So sometimes you'll see a workbench like this in front of the press, and there's water splashing around, and that's because it goes from a hot press to a cold press, and the cold press just makes sure that the surface of the EVA midsole, right? Because EVA is plastic, right? Make sure that that surface is firm so that when you pull out of the mold, the part doesn't get distorted or bent. Because if you take a hot EVA piece out of the mold and bend it and let it cool, it'll be bent, right? Um, okay, and that's actually sometimes where if you take an EVA shoe and you put it in you leave it in a hot car, it sits in a hot store window and it gets to be 150 degrees, the EVA will start to return to its original shape. It'll start to refoam, that's a bad thing. Okay, so all that talk about how the molds fit together. Well, this is a great example. This is where it's super important that your mold halves fit together right here, right? Because you want to make sure that and like this Jordan one, the color dam is essentially flat, right? There's a little bump here, right? But if you look at this thing, this profile line has all this zigzag up and down. So you really got to take a little bit more effort to make sure that these pieces fit together nicely, because otherwise your parts ain't going to look so good. Okay, So he here. Well, let's just watch this video for a second. We'll try to zoom in here, and I'll clear out of the way. So he's got the sort of the uncured rubber, the tangy taffy, sticking it in there. He's loading it. You can see all the mold texture in there. There's the top, so this is got some egg crate in it. Just lays it in there. And he's done enough of these that he knows exactly how much material needs to go into the mold. And you can see just literally cutting it with a pair of scissors, right? He knows how much he's... Okay, now, this is the middle plate. All right, now he's going to go cook that off. So there's the press again. He's cleaning up the middle plate. Now, the middle plate, the middle plate is when you're going to do... sorry. When you're going to do a two-color unit like this, the mold has two halves, and the middle plate takes up space in the middle. So you can actually load the black into the bottom and the white into the top. The middle plate is in the middle, right? And then you let the rubber cook about halfway. And then you pull the middle plate out, and then you close those two halves together on each other, and the black and white then will stick to each other and they will fuse. And that's how you end up with this beautiful parting line with no color bleeding, because the rubber is essentially cooked. So let's skip ahead here, and let's see what comes out here. So he's loading the mold, got the middle plate. Okay, here, that's a really good, let's zoom in on that. That's a nice view of what that equipment looks like, right? Pretty nice. Okay, let's keep playing here. Okay, he's got a little air to clean it up. Loading the middle plate. Okay, so now he's going to load the top half of the mold. All right. And let that go. Okay. Now, the result of that, let's see if I think we can show it here. Okay, there's the white, and there's the middle plate. Now he's going to, okay, let's zoom in on this, right? All right. This is pretty good. This is the business here. So he's opened it up. He's popped out the middle plate, and so you can see the white upper sidewall part is cooked. Now he's going to load. He's going to load the color into the bottom half. Same process, right? You know exactly where to load the extra material. Make sure all the logos spill. Yeah. Okay. And is this the finished one? There's empty mold. Okay. Let's fast forward here. We can see one coming out here. Okay, and that's probably the next one. Okay. Let's see. All right. Well, here's what that looks like when it comes out. So you can see this all looks a little bit gnarly, right? But because there's the parting line, right? And all the rubber is flashed out. But you'll notice that even though it looks a little smeary, on the parting line, the white and the pink are separate from each other. And here's the other side. And you can, and again, this part has not been trimmed. This looks pretty sketchy, but this is actually exactly what a well molded part looks like. Yeah, it's a bummer that this stuff has to get thrown away, but that's the case. And you can see where the parting line meets, and that's where the rubber's flashing, and this will all get trimmed away to make this a nice looking part. But yeah, you can see the texture is pretty well defined. It looks pretty clean. Yeah, this is a pretty nice mold here. All right. Okay. And yeah, this is the flash. I mean, again, it doesn't look that great, but that's totally okay. Um, let's see what's going on here. All right. So those pieces that they're putting into the mold, this is where those come from, right? This is automatic cutter, so this big strip of rubber goes out, and this machine is cutting those footprints to go in the mold. And you say, wait a minute, what about all this waste down here? Don't worry, this rubber is uncured. It just gets mixed up again and goes around the circle, and they keep cutting it, right, until there's none left, right? Let's see. I think we can show you a little bit of the mixer here. Let's see. Okay, so this is a mini mixer, and okay. So this is a big rubber mixer here. So the rubber, um, basically, it's a big, it's like cookie dough, right? And it comes out in a big stream, and then the last thing they do is they roll it up into a tube, right? And then they take the tube and they stick it, feed it into another one of these mills. See, there's the giant tube of rubber, and this thing is grabbing it, and it's literally like a giant spaghetti maker or the giant Play-Doh machine, and it rolls it out into there. And those brackets on this goes into a little powder to make sure it doesn't stick to itself, and then it goes through the water bath to make sure that it's all cool, it doesn't stink. Right? Now here's those sheets, and they're gonna just get taken right around the corner to the machine. This is that same pink color. Right? Okay. So that's how that works. All right. So we're looking at some EVA parts that come out of an injection mold. So here is some sandal footbeds, right? And they've come out of the injection mold. They've come out of the EVA injection mold, and they're going through a little cooling process to get them to the right size and to make sure they're stable. Now, so you'll often see this type of fixture in an EVA injection, right? So the pieces have been injected, and you'll notice they have sizes marked on them, and they will put these blocks on it so that as these things cool down, they maintain the right dimensional stability. Because if you take this injection piece out of the mold and just set it on the table, it could curl or it could shrink in a weird way, or depending on if it's a hot day or a cold day, the shrinkage rate might be different. And this is a little bit why EVA injection, you have to be careful about how you connect it to a piece of rubber, because the EVA dimension is not that stable, right? Because it's a block of foam. Okay, so here she's counting and checking, right? Because these pieces all are basically, this factory only makes these parts, right? So they're going to go out to the shoe factory because they just go piece by piece, right? All right, so this is that injection mold we were looking at before, right? You can see these inlet, right? And air, and actually this is the air escape side, and the back of the machine actually is where the material is injected. So this looks like kind of a sandal footbed. Okay, that's what that looks like. This is the back of the machine, and this head that has the mixing of the critical EVA, it just moves from. This is actually just a row of presses. I don't know if you can kind of see that. This is the press that opens up, and it's a press to hold the mold closed because this material is going in at a pretty high pressure. So the press has to hold the mold closed. And then this thing is on a conveyor, right? And it just moves from machine to machine and shoots, and then moves to the next one and shoots, and moves to the next one and shoots, because it takes a little bit of time once it shoots for the EVA to go critical and then to cool off enough. So you can't just shoot that mold every 10 seconds. It takes a minute or two to do the process, so that it basically shoots the row and then goes back to the start and then comes back and shoots the row. So for a high capacity machine like this, it can support maybe 12 molds at once. Conveniently, that's similar to what a size run is, right? Okay. So this is the back of that machine, and here's all the presses. And this is a pretty, you don't want to be back here. This is not a nice place to be. Okay. So yeah, hey, you know what? Not everything is we like to mess around. Okay. So not everything is all hard work. Hey, these factories are not open. If there's a lot of business, they'll be open on Saturday, but on Sundays they're off. So my friend Gary and that gal Coco were just messing around there. They walked me around. We tour around, and he took me to these really amazing temples. And that's a giant incense burner, and it's just really cool to. Hey, we're here. We're adventuring, right? So let's get a look at the culture that we're in here. Um, let's see here, and I know we've got okay. There's plenty more tooling to get to here. Are you done yet? Do you want to move on? We still got more here. So this is just outside the tooling shop. The truck pulls up, and here we are. Here are the molds. Just they've come from the casting factory. They're the raw casting, and actually is it this one? No, almost, but looks like it could be, but not quite. Um, so here are the molds. They just showed up on a flatbed, and they're gonna go in and finish their processing because this factory does all the CAD modeling and they make the wooden molds, but the casting is done outside because that's a really very different. They're very different kind of business, right? Okay. So here's the guy. They're working on some molds. You can see there's a sandal mold going, and they're doing exactly the same. They're doing the same thing now. These guys have something a little different here. You can see here. This is the internal mold for a EVA injection sandal, right? So if you're making like a croc, the outside mold pops off, right? And that could be this piece over here, up here. But the inside has to have its own shape too, right? So this is what makes that inside shape. Um, all right, let's see what else is next here. Okay, so same thing. There's a size run left and right, all prepared because this is going to the casting shop. All right, this is an injection EVA, and I took a picture of that because man, that color distribution is pretty wild. I don't know how they did that. But let's take a look at some other pieces. So here's some raw castings here. Um, they haven't. You can see that surface, the mating surface is rough. It hasn't been finished yet. And here's the scan dots, right? And they're ready to work on it. And you can see that looks like pretty popular brand there. And okay, so again, some more raw castings. Let's see, what does that say? I can't read the logo. Okay, so here is inside the CNC machine, and this metal work is this is where that computer controlled machine is going to go ahead and clean up that mold, right? And it's already been scanned. And here, actually, this is where they're making these wood cuts, right? Uh, and you can see the 4-axis or 3-axis milling machine doing these. Okay, upstairs we saw the computer design department. Now they've taken that computer model and they're going to make the computer design department. Now they've taken that computer model and they're going to make what we call the wood cut. So if you look inside here, the CNC machine is cutting this soft material, and this will be used to confirm the design, but also these components are used in the casting manufacture of the metal mold. One second here. Sorry, we're gonna feed the dog. Okay. She really wants to go out and play. Okay. Just a few more minutes, folks, and we'll get on with it. Okay. Um, let's see. So let's come down here. So here, okay, so here's that EVA injection machine, but you'll notice this is just like 2 stations, right? Or 3 stations. This is the baby one. This is they're testing the mold, right? Before you send the mold to the production department, the mold has to be tested. So this factory is actually a pretty big deal. They actually have that test equipment right inside the factory. Because that other machine is in a different area. So here's all the molds piled up, and now these molds could be some of these molds look like they're already used, and that it could be true because molds often need to get serviced, right? Or if they're being transferred from one molding factory to another, maybe they'll come back and get a little Teflon coating or just a little cleanup before they go into production again. So here's a raw mold again. Um, here you can see this is injection molding, right? Because you can see the ports, right, for the flow, and all that red dye, right, is because they're trying to make sure they fit together tight. And here's the operator. He's now got the other half of that mold, right? So there's the 4 pieces. Here's the other side, and you can see where the red's touching, right? So those are the high spots. So he's going to go ahead and just give those a little polish to make sure that all of these areas are flat down together so that the flash is to a minimum. In these molds, you don't want to have very much flash at all. right? And so here they're working. Okay, so there you go. You can see the this is a fancy midsole. It's got those finger holes in the middle of it, and that's what that crazy. Actually, that's what this tooling is. This metal. This is actually the mold. This mold is a little unique because it's molded like this, not like this, right? So it's sideways. Those fingers are penetrating, and so when you make a mold, you have to really think about the design you're doing to make sure that the mold would actually open and close correctly to get the shape you want. So to make a part like this is quite unique. So it actually the mold has to open two different ways. Okay, again, this is the internal mold for some injection piece, right? And well, yeah, what's that green? This is all the Teflon coating, and now this mold you can see has to open sideways, right? That's why it's got that unique shape to it. So this mold is almost finished. What's missing now is this Teflon coating, but you can see it's got texture on it, all the details there. Its whole thing's been lightly acid etched or sandblasted. It's really, really clean looking piece of equipment. Let's zoom in on that. Yeah, that looks pretty nice. What's that say? Oh, Calvin Klein. All right, pretty nice. Okay. Um, here's a Puma. So I say, wait, how could you show three different or four different brands all at once? Well, the answer is this is a mold shop, right? They don't take orders from any shoe factory in the neighborhood, right? So if you've got a shoe factory that's making two or three different brands, then you'll have all this different equipment in here. And yeah, I mean, does that mean a Puma guy might see the other guy? He might, but at this stage, it's done. So yeah. Okay, so what's going on here? So this actually this this picture like upside down. What's going on here? Oh yeah, hold on. Okay, that's better. So what this is they've got a cup sole and they're looking at the sidewall and there's some issue with it, right? So they're marking the defect on the mold so they can go back in and they can go back in and either polish it or buff it or make some correction to it, right? Again, here's the pink stuff, and here's the worker. Basically he's doing a little work on the middle plate to make sure that it all fits. This guy's a class act. I love that. He's rocking a cigarette. Yeah, just working away. Yeah. So he's go ahead, smoke your cigarette, man. Just doing his grinding. That's how it works, man. Okay, so there you go. There's the mold die, and all right. So that's it for the tooling section. Now let's see if there's some more here. Well, we're just talking about tooling and equipment. Um, yeah, I guess that's kind of it on tools and equipment. But yeah, you can see, this is tooling is fascinating because you can see there's a ton of equipment, right? And there's a lot of handwork too, right? There's still some artistry. Even though you use the CNC machine and you do the metal casting, there's still a lot of handwork to make sure that those molds fit together perfectly. And whether injection mold or rubber compression or EVA compression or EVA injection, it's all the same. You make the mold, you scan, you do CNC, and you do have to come back and do hand finish to make it perfect. And so there's a lot of work for these folks, and this work takes time, right? So when you're opening a new mold and you say, okay, so you've confirmed, it's amazing that they can make, when you have a new design, they can make it in a month, right? um, these EVA combination pieces take a little bit longer because you make the rubber piece, you make the EVA piece, you got to make sure they fit together, right? So so tooling, it takes a lot of effort, takes a lot of time, takes a lot of money, right? Because there's a lot of equipment and people involved to get this stuff done. But again, once you see how durable all this equipment is, this is all metal equipment, whether it's aluminum or steel. So um, how long will these molds last? Years. If you're a couple 100,000 pairs, easy, right? And at that point, if you're selling a few 100,000 pairs of a shoe, if you have to make a new mold, big deal, right? You're making money. It's good business, right? So that's tooling, folks. If you have any more questions about it, feel free to contact me, the Shoe Dog at Shoemakers Academy. We have a ton of stuff on the website. Of course, we have books, we have courses. Um, let's go take a look. Actually, while we're here, I want to I want to make sure you guys can find the stuff here. So come to shoemakersacademy.com. Here it is, and we have online courses, and we have a ton of books. And in the courses, we'll talk about stuff like this, right? So there's we have beginning courses, we have business startup courses, we have material courses, we have quality and inspection and authentication and costing, all that good stuff. And if you want to learn more about tooling, then come check it out. Thanks a lot.